Alright, so to close out our first section here on probability, we're going to take a look at a standard deck of cards. And by a deck of cards, I mean the 52 cards with the aces, the kings, the queens, etc. that you'll come across. And when we do problems with probability with cards, there are always kids who try to use as an excuse the fact that they don't know what a deck of cards looks like. So people assume just because they don't know what a deck of cards looks like, they get a free pass on these problems right here. I'm telling you right now, deck of cards problems come up a lot, enough so that you need to learn what a deck of cards looks like if you don't already know. So I'll say that again. Not knowing what a deck of cards looks like is not an excuse. On this slide right here, I'm actually going to teach you what a deck of cards looks like so we can use it to answer some probability questions. So you do need to learn what a deck of cards is like if you don't already know. So the deck of cards, there are 52 cards, and they're broken down into 4 suits. Suits are like the little shapes that are on the cards. So there are 2 types of cards that are red. There are hearts, and there are diamonds. And then there are 2 types of cards that are black. There are spades. I'm not going to be able to draw this super well. Spades like the little shovel-looking thing. And then there are clubs, which I won't really even try. I'll just make some dots here. So clubs, spades, diamonds, hearts. There are 4 suits. That shape is on every single card. 2 types of cards are black cards, and 2 types of them are red cards. The cards run all the way, a lot of the cards are numbers, so they all start with something called an ace. There's an A for ace on each one, followed by a 2 of each type, followed by a 3 of each type. It's going to keep counting all the way to 10. And so like the numbers 2 through 10 are represented. And at the end of the deck of cards, there are what we call face cards, which are the ones with the people on them. So there's a jack, a queen, and a king. So every suit finishes with jack, queen, king. So a couple of vocab words just going along with decks of cards so you're familiar. These cards at the end with the people on them are called face cards. Face cards are cards that literally have a face on them because there's a person on the card. So aces do not actually count as face cards because there's no face on them. Jack, queens, and kings are face cards. Each suit of cards right here has 13 cards in it. So there are 13 hearts, 13 diamonds, 13 of these. So there's 13, 13, 13, 13, which gives me a total of 52 cards. So knowing that, and again, you need to know that, we can answer a few probability questions here. Let's take a look at the following. We're going to pick a card at random out of a deck. We want to know for the first problem, what's the probability if I pick a card it's going to be a 5? Well, there are 4 5s in the deck, 1 of each suit. So you can look at the little chart we made right there and count them out of 52 cards. So you can either reduce that, you'll get 1 over 13, or if you prefer, you can write it as a decimal. If you pick a card at random, the probability it will be a 5 is about 7.7%, 0.077. Okay, second one, probability of a red card. Remember, red cards are cards that are red, that being the hearts and the diamonds. There are 13 hearts, there are 13 diamonds. That makes 26 red cards out of the 52 cards altogether, which is 1/2, which is 0.5. So there's a 50% chance if you pick a card at random, it's going to be red. Face card, we have, remember, jacks, queens, and kings, jack, queen, king, are going to be our face cards here. So there are 3 of those per suit, 4 suits total. That makes 12 face cards out of my 52 cards here. And if you are to reduce that one, you should end up with 3 over 13, which if you write that as a decimal is going to be 0.231. Finally, we have the probability that a card is not an 8. 2 ways of going about this. One, just think about it. If there are 4 8s in the deck, that leaves 48 other cards out of the 52, which reduces to 12 over 13. Or, if you wanted to use that complement stuff that we talked about in the last video, you can do 1 minus. The probability of getting an 8 is 4 out of 52. You turn this into a fraction, it'd be 52 over 52. You still get 48 over 52, which you can reduce. So, knowing a deck of cards goes a long way towards calculating basic probabilities.